I'm going to define our repositories folder inside of our infrastructure project, and we're going to define our repository classes inside. The first thing I'm going to add is a generic repository base class, which is going to inject our database context, and it's only going to implement two methods that we're going to need: the getById method, which fetches an entity by the ID, and the add method, which adds an entity to the database context. The important thing here is that we have a generic constraint on our repository class, which requires that the generic type implements the entity base class. So now when we implement the repository, because this is an abstract class, we can only do it for our entities. So I'll go ahead and add the user repository class. And if we take a look here, it's implementing the repository of user base class and also the iUser repository interface. This interface has two methods, getById async and user, and both of these are satisfied by our generic repository base class. In my opinion, this is the ideal way to use the repository pattern. In your domain layer, you will define specific repository interfaces containing only the methods that you need for that entity, and in the infrastructure layer, you can leverage the generic repository pattern to reduce repetitive code. Let me add the apartment repository, which is going to be similar to the user repository, where the generic repository already satisfies the interface. And I'm also going to add the booking repository. This one is slightly different in that it has a specific method, which is the isOverlappingAsync method, and we have to implement this in the repository itself because it's not satisfied by the generic repository. This method is interesting, and it implements the optimistic check to see if there are any bookings for this apartment in the specified date range. So here's the condition doing those checks, and we also need to check that the booking status for this date range, if it exists, is one of the statuses that means that there's an overlap, such as the reserve, confirmed, and completed status. If you remember the search apartments query handler, which we had in the application project, it was doing a very similar check to this one. Now let's register our repositories with dependency injection. I'll head over to the dependency injection class, and after configuring my database context, I'm going to add the service registration for our repositories. So we have the user, apartment, and booking repositories defined as scoped services. I'm also going to add the registration for the iUnit of work, and I'm going to use the service provider to resolve the database context and use it as the unit of work implementation. In the application project, we had the SQL connection factory abstraction, and this is also something that we should implement in the infrastructure project. So I'm going to add a new folder in the infrastructure project, and I'm going to call it data. I'm going to add the SQL connection factory inside, and all it does is implements our SQL connection factory interface. It's going to create a new MPG SQL connection. We have access to this type through our Entity Framework provider, which is also using MPG SQL under the hood, and this is the database provider library for the PostgreSQL database. We're also going to open the connection after creating it, and we're going to return it from this method. One more thing that we need to add inside of this folder that is related to Dapr is having a date-only type handler. Because I'm using date-only types in the date range value object, I need to tell Dapr how to be able to map this type, because it doesn't support it out of the box. To do that, I need to create a type handler and specify the date-only type, and then I need to implement the parse and set value methods. They are going to be invoked when sending a date value object to the database or materializing one into memory. We also need to configure this with dependency injection and Dapr, and a good place to do that is the dependency injection class. I'm going to add the required code. So for the SQL connection factory, I'm configuring it as a singleton service, and I'm creating a new SQL connection factory instance and passing it a connection string. For the type handler for Dapr, we're calling SQL mapper and the add type handler method, and now our Dapr queries using the date-only type are going to work correctly. I mentioned that I'm going to show you how to publish domain events using the unit of work pattern, and the class implementing our unit of work is the database context. So let's see how we're going to use our EF Core database context to publish our domain events. We're going to start by overriding the save changes async method. I'm going to make it asynchronous, and I'm going to paste in the implementation. So this is what the flow for publishing domain events is going to look like. We're going to call the base save changes async method. Then we're going to say await publish domain events async, and then we're going to return the result of our save changes async call. So to be able to publish domain events, I'm going to inject the iPublisher interface from Mediator inside of our application DB context constructor. So let's go ahead and add that. And now I need to add the publish domain events async method. So here's what this method looks like. It's going to use the change tracker on EF Core to grab the entity entries which implement the entity class. If I go to the entity class, you'll see that we have a list of domain events inside, and we are interested in accessing the elements of this list and publishing them using Mediator. If we go back to the application database context, we are selecting the actual entity entry instance, which is our entity class. Then we are calling select many to map the list of domain events from each entity. We are calling entity get domain events and saving them in a variable. Then we are clearing the domain events from our entities and returning the domain events. This part here, where we are clearing the domain events, is important because when we publish the domain events, we don't know what could be happening in the handlers. There could be another database context created, which could use the same entity and add another domain event, and this is going to cause strange behavior. So we have the domain events extracted, and then we just iterate over them one by one and call publisher publish to publish the domain event. This is going to trigger the respective domain event handlers which we defined in the application layer. I think it's important to discuss the caveats of this approach to publishing domain events. So what we are doing here is potentially problematic. We are saving changes to the database, and okay, this is atomic, and this is either going to succeed or fail. But then we are publishing a set of domain events, which is another transaction altogether. The domain event handlers could be doing all sorts of things, like calling the database or other external services, and the handlers themselves could also fail. This is going to cause an exception, which is going to fail the save changes async method. However, the original call to the database was already successfully completed. So in the case of a domain event handler failure, it would appear as though the whole transaction failed, but that wouldn't be the case. This is a major concern with this approach, and it's something that you need to be aware of if you want to be running this in production. There are also implementations that go ahead and publish the domain events before calling save changes async. The reasoning is then the handling of the domain events becomes part of the overall transaction by EF Core. While this is inherently true, the whole concept of an event is something that is a fact. An event is something that has already happened in your system, and publishing the domain events before actually persisting the original changes that triggered these events makes absolutely no sense to me, which is why I go ahead and publish my domain events only after persisting these changes in the database. In one of the next chapters in this course, I'm going to show you a more robust way of publishing your domain events using the outbox pattern, and until then, we're going to leave the implementation like this. One last thing I want to implement in the infrastructure project before we move on to the next chapter is support for optimistic concurrency in order to solve the race condition that we have in the application project. Here's the approach that I'm going to take. I'm going to go back to the application project, and I'm going to add a concurrency exception inside. This is just a simple exception accepting an inner exception in the constructor and some message. The question is now, how are we going to use this concurrency exception? So I'm going to head back to my application database context, and I'm going to update my save changes async method into this. We have the previous implementation inside of a try statement, but we are catching the DB update concurrency exception. This is an exception that is thrown by the database when we have a concurrency violation at the database level. The reason for creating a custom exception is so that I don't leak Entity Framework details into my application layer. I'm abstracting Entity Framework behind this custom exception. However, I'm passing in the exception instance as the inner exception so that it's available for logging and further inspecting. So now our database context, which is our unit of work, is going to be handling the database update concurrency exception and throwing a concurrency exception instance, which is known to our application project. This means that we can go to our reserve booking command handler and adjust the current implementation with this one. Now we have a try catch statement. The code inside of the try block is the same as we had before, and we are catching a concurrency exception, and we know that this is because we have an overlap at the database level. So somebody else managed to reserve this booking before we could, and they win. We return an overlap error. On the client side, we could retry reserving the booking again in case this was a transient failure. Otherwise, we're going to fail here if somebody actually did manage to reserve a booking before us, and the user interface should handle this accordingly. There's one missing ingredient to how all of this connects together to implement optimistic concurrency support. Optimistic concurrency is a mechanism that relies on having some column in the database acting as the version for that row. Usually, this is a database generated value, and it's used when persisting changes to the database to check if the version that is currently in the database is different from the one that we have in our application at the time when we loaded the entity. If those versions are not a match, it means that somebody has changed this row in the database before we could, and we throw a database concurrency exception, which is the case that we are handling here. So what are we going to use for our row version? We can't use the booking because it doesn't exist in the database until we call save changes, so that leaves us with either using the user or the apartment. If you look at the booking reserve method, we have a nice little call here setting the last booked on value to the current UTC now time. This is going to trigger an update on the apartments table for this specific row, which we are making a booking for. So we are going to define a row version column on the apartment entity, which is going to help us implement optimistic concurrency. To show you what this looks like, I'm going to head over to the apartment configuration, and we are going to add this configuration here. So what I'm doing is defining a shadow property on my apartments entity, which I'm calling version. I'm using unsigned integer as the type for the row version, and I'm calling the isRowVersion method, which is going to tell EF Core that this column should be interpreted as a row version for implementing optimistic concurrency support. The really nice thing about the Postgres implementation of optimistic concurrency is that it's going to use a system column, which is the xmin column, and it holds the value of the last updating transaction. If you want to read more about it, I'm going to leave the documentation link under this video, and for now, you can just assume that this functions as expected, and we have solved the race condition in the reserve booking command handler.